Hello and welcome to this Mentor Graphics Electrical Systems webinar. My name is Andy Cooper and I am the Product Architect for the Harness Solutions products at Mentor Graphics Integrated Electrical Systems Division. The title of today's webinar is Automating Production Module and Subassemblies for Modular Harnesses. In the next 45 minutes I will illustrate how Mentor Graphics harness engineering tools enable harness manufacturing engineers to define and decompose harnesses into production modules meeting specific factory know-how and constraints. This webinar is one of a series looking at how companies can find the best balance between cost and complexity in electrical design and also the manufacturing optimization challenges facing today's harness makers. In the last couple of webinars, my colleague Elisa Pouyan presented how automation can be used to help address the challenge of ever-increasing complexity in the areas associated with wire harness design. In this presentation, we'll consider the challenges facing harness makers in determining how best to reslice the design data to best suit their manufacturing capabilities and preferences. This is a slide you may have seen in previous sessions, and in those sessions you will have heard about the various challenges and solutions associated with the management of complexity throughout the design flow, affecting the various areas shown in this slide. For today, however, we'll be focusing on the challenges associated specifically with harness manufacturing, irrespective of the design methodology used. Today's agenda looks like this. I want to start with a brief introduction to Mentor Graphics, the company, what we do and which markets we're in. I'll then take you through an overview of the typical manufacturing challenges facing harness makers in the area of how to repurpose the design data such that it can be decomposed into suitably sized and structured production modules or subassemblies. Next, I will illustrate how Mentor software can help in the following areas. Firstly, the capital extensions infrastructure, and this is the enabling technology behind the next important point, which is our capability for automated module assignation via plugin. I'll then demonstrate our interactive module assignation and visualization capability, and then I'll demonstrate our module processing and reporting features. If you have any questions during this webinar, please use the chat window and I'll take time to answer these during the Q&A session at the end. Mentor Graphics is one of the world's leading electrical design automation companies, with offices in every corner of the world, providing software solutions for the design of chips, PCBs and electrical platform design, including wiring and cabling, with sales greater than $900 million and over 4,400 employees worldwide. We provide electrical wiring and cabling design products for all the sectors of the transportation market, including defense, aerospace, car and truck companies, and also small to medium-sized companies producing more specialized products. And irrespective of the domain, all our harness making customers face the same challenges of working out how best to decompose the harness designs into pieces that will enable a smooth, cost-optimized manufacturing process. So now let's take a look at this challenge, that of repurposing the design data into production modules or subassemblies. This slide should help set the context. Here we can see a typical composite parent harness in which the objects may be option tagged in order to allow decomposition into, for example, finished derivative buildable harnesses. The composite harness could also be tagged with functional module codes to enable decomposition into the electrical features or functional modules. And these are the two design methodologies you will have heard of in the previous webinars. Irrespective of which methodology you use in the design, the harness maker has a need to reslice this data in order to suit his manufacturing process. And here we can see the same data tagged and decomposed into a number of different modules that don't match either of the functional or derivative definition, but in combination can be grouped together to make either of the derivatives or either of the functional modules. And it's this assignation process that we're talking about today, and in most cases this assignation is driven by very specific customer specific rules. Let's take a look at an example assignation strategy. A typical methodology is to try and identify modules whereby all the wires can be directly inserted into the connector housings, reducing loose wire ends, and ideally find modules with wiring just going one-to-one between two connectors. After that, 1 to n modules would be preferable, and after that we would try to minimize the number of loose wires where wiring would need to be inserted into the connectors at a later final assembly stage. Now we'll take a closer look at an example assignation rule that would implement such a strategy. First off, we need to start somewhere, so a sorting rule is typically used. For example, start with the connector with the most wires in. And in my example here, this is connector A, which is a 20-way connector. Then we need to identify all the other connectors that have got wiring attached to connector A. So the red path is indicating which wires go to which connectors, and in this example you see no wires go to connector E, so that can be discounted from this initial pass. Next, we need to analyze the number of wires connected to each of the attached connectors. And here I'm showing, for example, connector B has 5 of its 8 wires routed from connector A. And in my case, my rule is I want to include attached connectors where 50% or more of their wires are attached to the first connector. And this will create my first production module. Now in this case, I need to discount connector E because it's only got 1 of its 3 wires routed to connector A. So this defines my first production module. Those componentries would be assigned to that first module, and then I'd start again and continue the process, working through the harness to create the production modules according to this rule. That was an example of a simple assignation rule, and you can imagine varying that rule, for example changing it to start with the smallest connector instead of the largest connector. But the reality is that the rules driving the assignation of components into production modules vary according to many factors. Let's take a look at some examples. First up, process preferences. The use of rotary assembly lines versus static single form boards would significantly influence the way the modules are structured. The availability of machinery and tools. A certain plant may have automatic module assembly machines that only work with certain families of connectors. Another factory may have board-mounted splicing tools as opposed to making the splices offline, and this again will influence the way the modules are structured. Line balancing is another consideration where component counts, for example, would constrain the contents of each of the modules. When working on a composite design, your production module designs need to respect the fact that components may have functional codes or options assigned to them with relationships indicating what can and cannot go together. So this maintenance of functional boundaries is also another consideration. And there may be specific component attributes that may drive your decisions. For example, a certain type of high density connector may have a necessity to fully load all the wires in one module because of the difficulty inserting wires in a partially populated connector. So the fact is, organizations need a very flexible way to plug in their own rules into our module assignation functionality. So how can Capital Modular XC help? First up, I want to talk about the enabling technology that is the Capital Extensions infrastructure. The Capital tool suite is built for flexibility. We've got a multi-layered infrastructure for embedding an organization's unique intellectual property. Out of the box, the standard products are highly configurable, which allows business practices to be directly embedded. On top of that, we've got a bridges and web services architecture that allows rapid integration with the enterprise, changing the economics of integration. And finally, we have an API which allows resilient customizations to be quickly developed, protecting intellectual property. And it's this extensions API that is the enabler for our production assignation algorithms, and it allows you to develop your own custom extensions. We have a fully documented development kit available through both JavaScript and Java. A little bit more about this. A custom extension or a plugin exploits the Capital Extensibility API. we have Java interfaces based on a robust, purpose-built business object layer, and this provides access to CHS objects such as wires and connectors, their attributes, e.g. cross-sectional area and colour, and their relationships, allowing you to navigate, for example, from the connector to its terminals and so on. Advantages of the CHS Extensibility API. Developed extensions are independent from underlying CHS internal data model. The business object layer functionality is consistent between CHS releases, meaning that existing custom extensions and plugins can be reused in different CHS releases, meaning any investment you make in custom extensions is preserved over time. We provide read-write access to the business objects, attribute and properties exposed, and we give you full navigation and access on all the linked CHS design objects and components. So this allows company-specific extensions to fine-tune a CHS deployment and to implement customer-specific rules and processes. The Extensions API support is available in numerous areas of functionality across the whole Capital tool suite. But with regard to plugging in your own custom production module assignation routines, we're going to be focusing on the area known as constraints. Now, before we move on, I just want to talk about a typical use case. It's expected that the initial production assignation would be automatically completed via the use of a plugin routine. The experienced process engineer would then use the interactive tools to adjust and complete the assignations. So I'm going to demonstrate these two key stages in the next two pieces of the webinar. So now let's take a look at how we can perform automatic module assignation via the use of a plugin. So here we're looking at Capital Modular XC. I'm just going to look at the plugins I've got loaded on my system, and here you'll see I've got a custom production module assignation constraint loaded, ready for use on my designs. So to make it applicable, I'm going to edit this design and apply a rule as a constraint being assign module codes via a plugin. And then I pick from my available plugins, here I've just got the one there, the plugin routine that I want to use for production module assignation. Then to run the plugin, I'm going to perform the processing action for modular designs, assign production module codes, and the presence of that plugin applied to this design will take over this activity, and the assignation will be performed according to the rules in the plugin code. The assignation routine has provided us with some information messages about which connectors have been assigned to which modules, and we can see there are a couple of connectors that fail to satisfy any of the rules for assignation. We can see more details by looking in the production module code browser area here, where we can see for each of the modules assigned, sub 01 for example, we can see the connectors that have been assigned to that module and the wires, and we can expand that for each of the different sub-assemblies created. In order to get a better preview of the content, we've got a dimmer capability here where we can turn this on, and via the use of this slider on any selected objects we can get a contrasted view of what those objects are. So that would be the content of sub 01, sub 02, 3 and 4. So navigating through the objects here with the dimmer switched on, you get a nice preview of the potential content of those modules. Now that assignation routine is following pretty much the algorithm I demonstrated earlier, working through the biggest connector down. And as also mentioned, we know that the production assignation routines would vary wildly based on lots of different factors. So you could have a number of plugins corresponding to each of your manufacturing capabilities. However, you can also make the plugin routines respond to other attributes already present on the design or on the design objects. So I'm just going to demonstrate how we can build in a little bit more flexibility. First of all, I'm just going to remove the assignations that I've just created. So I'm just going to clear all those. And what I've got here in my assignation routine, I've got the ability for it to respect and work on a property that I have assigned to the design. So here you can see assignation sort order property that I've added that's currently working off the value highest. Now if I change that to lowest, the algorithm is going to run in reverse. It's going to start with the smallest connector and build up from there. So we should get quite a significantly different result this time round. So I can run it again now. I'll switch on the dimmer, and we can see now that the content of the modules is significantly different, but it's based on the rules of starting with the smallest connectors and working up instead. And so that's just an example of how you can vary the flexibility of a particular routine just by adding some properties on the design and using the values of those properties to change the behavior of your plugin. Now it may be that your automatic assignation routine is comprehensive enough to 100% complete the module definition for a design. However, it may be that some components have fallen through the loop and need some manual intervention in order to complete the assignation. And in order to best demonstrate the interactive capabilities of the tool, I'm actually going to clear the assignations and demonstrate a ground-up approach to manual assignation. So having cleared out the assignations created via the plugin, I now have a whole design full of unassigned components ready to be worked upon. Now I've got this Production Module Explorer tab that I've enabled here, which is a working area for me to do some analysis on the connectors. What I can do, I can just drag all the connectors in there, and I can use these sorting options to sort on the number of cavities, high, low, low, high, number of wires, and number of unassigned wires. As I work through the design, some of the wires are going to get assigned to modules, so I may only be interested in the wires connected to things that are yet to be assigned. Now in my case, I want to start with this big connector and find all the wires attached to it. So I can remove the unselected objects with that button there, and then I can add into this browser all the unassigned wires for that connector. I can select everything in here, and as is normal in all the modular tabs, I can switch on the dimmer and preview the likely content of that module. Now if I'm happy with that content, I can actually just take all of the content from the Explorer, drag it over to any of the modules in the module browser, and let go, and all the objects are now assigned with that module code. So there's the connector and all its assigned wires, making my first production module. I can then take the unassigned connector node again and drop in all the connectors that remain. You can see I'm now working from the 16-way connector, and my process can continue. I can now remove all the other connectors I'm not interested in, get me the wires attached to that connector that have yet to be assigned to a module. Let's take a look at that, see what it looks like, and if I'm happy with that content, I can drop that into sub 02 and create the next level of module. Now as we continue through this process, the modules are going to get smaller and smaller, and so we may start to be interested in making a module assembly that combines two or more connectors together. So let's take an example of how we might do something like that. So I've still got a connector with a fully populated set of wires here. I'm just going to do the normal process of selecting the connector and its associated wires, but rather than directly assign this to a module, I want to store this connector and its wires for potential inclusion with some other connectors. And to do that, we have what's called the scratch pad, which is a temporary working area, holding area if you like, where I can put these objects for assignation later on. But I want to see what else I might want to merge with the connector M. So if we zoom in onto the diagram a bit, we can see here we've got M, N and O are in a common area. I think from before we saw that we still had N and O as connectors that are not yet assigned. So I'm going to work through those two connectors as before, getting the wiring associated with each, but now I'm going to drop them into the scratch pad. And then finally O was the one that we were interested in. Let's get the wires for O. And now I can drop all those objects into the scratch pad, and I can preview that as normal with the dimmer and look at the content. Sorry, that's just a single connector. Let's select everything. Say, okay, that looks like a decent sized merged module. And then what I'm able to do, I can actually drag directly from the scratch pad to populate a module from there. Now let's take a look what's left. A few connectors now with some wires attached. So let's repeat the process for this one. And we'll go ahead and make a module directly from that. And now we can see we've actually got no more unassigned wires. So all the wiring based modules have been created, and we've managed to spread them into 4 different modules. We could take another look at what they look like. Turn on the dimmer. So we've got sub 01, 2, 3 and 4. But we've got a number of connectors that need to be allocated and assigned to one of those modules. So we can work through these in sequence. Now what we can do is say, okay, connector A, let's just turn off the dimmer. I want to see where that is on the diagram, so I select it on its diagram. I can see it's there. I can press the Z button to zoom in on that connector, and we'll look at the table, and we can see that the majority of the wires terminating at this connector are actually coming from sub 01, and using our 50% or more wires attached rule, then we know that it makes sense for that connector to be included in sub 01. So I can just drag and drop that straight into sub 01, and we can see that's included in sub 01. And I can repeat the process for the other components. Connector B is also sub 01. Let's have a look at D. Zoom to there. Here we can see all its wires are attached to sub 02. So that's a simple one. Drag that into sub 02. This one, again, the majority are in sub 01, so F should go into 01. G, again, majority in sub 01. I, we've got a split here, but majority are in sub 03. J, well, that's shared between 2. I may choose to leave that connector on its own and add it to a form board as its own subassembly, or I could arbitrarily assign it to one of the existing modules. In this case, I'm just going to put that one into sub 04. And K is a sub 02. And L, which is there, let's just pan over. We can see that needs to go to sub 01. And there you go, I have no further unassigned objects. My modules are complete. Turn on the dimmer so we can get a bit of a preview. So sub 01 is going to look like that. Sub 02, 3 and 4. So at this stage my interactive assignation is complete. And as mentioned, the large proportion of that work could have been automated via the plugin, and then it could be down to me as the experienced user to finish off the components where the plugin failed to assign, or analyze the smaller assemblies and choose to merge them into bigger ones that would be better suited to balancing my production, or split out some of the large ones to make smaller assemblies for the same reason. Either way, with the interactive tools I can finish off my assignation to get me to a condition that you can see here. So having assigned all the components to their target modules, we now need to do some processing in order to automatically decompose that composite design into each of its individual module designs. So I'm now going to show you how we go about doing that module processing and subsequent reporting on the modules. So here with my composite harness selected, I'm just going to invoke the harness processing wizard and work through the steps. So what I want to do is perform module breakdown and that tells the system to decompose the composite into the child designs. Then on each of the child designs I want to perform harness engineering, which is going to run a number of calculations. And then also for each of the child designs I'd like to perform some design rule checks. At the bottom here you can see 4 available design containers waiting to be populated, and these correspond to the 4 module codes that we actually use during our assignations, and I've pre-prepared these ready for population during processing. And I'm going to choose to populate all 4 of them and then move on. I get some preferences for the breakdown step. Here you can see reference diagram. If I had more than one diagram for the composite, I can choose which of those diagrams I'd like to automatically create a depopulated version of for each of the children. In this case I only have the one anyway, and there's a few preferences and options I can select during the breakdown process. For example, merging common installations at redundant takeouts. Here's the main engineering list of options, and these are all the processing steps to calculate the wire lengths, installation totals, selecting all the corresponding part numbers for each of the parts, etc. So we'll leave all those switched on. And finally, all the various design rule checks that I may want to perform on each of the resultant child designs. Some may be more applicable than others, but I'm going to leave them all switched on for this exercise. I then get a summary of what's going to happen. I'm going to break down 4 of 4 child designs, do the harness engineering on each and the harness checks on each on the designs listed below. And off the system goes. So this is taking the data from the composite, looking at those codes assigned to the objects and pushing the corresponding objects into each of their child designs. Then the engineering calculations does the length calculations, the diameter calculations and the quantity calculations, and puts the relevant part numbers on each of the components that have got any part numbers yet to be selected. And now we will see in the production modules folder the 4 designs that the system has populated, and we can open up each of those diagrams. You can see there is the actual content of module 1, module 2, module 3 and module 4, and so we can look at each of those diagrams in the tabbed mode there, and can zoom in and out, and the design content is listed on the left. Now for each of these modules we might want to get the reported information, such as we may want to get a component bill of material for this design. So what we're seeing here is the embedded reports that are shipped with the system, but of course users can configure their own style and format and content of reports to suit their own particular factory needs. We could have a wire cutting chart, for example. And we also have a wire list, which would be a typical from-to report for each of the wires. So that completes the demonstrations for today. So now let's summarize. First off, I explained the need to reslice the data to suit manufacturing. Here we were talking about the fact that irrespective of whether the harness has been designed as functional modules, derivatives or just single harnesses, the harness maker has their own reasons for decomposing the harness into different structures to suit the manufacturing facility. I gave some examples of the kind of reasons why the harness would need to be broken down into different structures, and then I gave a detailed example of one particular assignation rule for connector and wire groupings. I then explained a little bit how the Capital API framework enables the use of plugins for customers to create their own assignation algorithms and build them into Capital Modular XC. And then I showed you how we could do that, and I ran an example assignation plugin in order to create the first steps of wire and connector groupings. In order to complete the assignations, I then demonstrated how the powerful graphical interface in Capital Modular XC enables the user to even do a ground-up assignation manually, and obviously it allows you to complete any assignations already run via a plugin algorithm. And then, having completed the assignations, I showed how the automatic processing capabilities will automatically decompose the data from the composite into each individual module data set, on which we can create the various reports as required. So I'd like to thank you for attending today's webinar, and now mention the next webinar in the series, the topic of which is automating the generation of VIN-specific service documentation. This is a change of emphasis from today's webinar, and we'll be looking at the topic of creating the vast amount of wiring diagram information that needs to be generated to support the service technicians at service centres. In the webinar, we'll be showing how some OEMs are now using an automated process to deliver the vehicle-specific wiring diagrams to every service technician, simplifying the service process and saving time and cost. For more information, you can visit us at our website www.mentor.com/electrical, and you can also revisit this webinar or others in the series online at the link shown below. That said, that now leads us into the Q&A session, where I'll try and answer any of the questions that have been posted during the session. Thank you very much.